There are, of course, a number of different valid approaches to working memory, of which ours is just one. And I think one of the things that characterizes it is being influenced by practical issues, being influenced by patient studies, and probably that resulting from that, a use of dual task interference paradigms. So the way in which one uses interference, for example, let's take the case of the phonological loop and the idea that verbal rehearsal is an important part of that. What we want to do is to set up a situation in which we remove the capacity to use verbal rehearsal. If you like, it's a bit like the neuropsychological paradigm of finding a patient who doesn't have that capacity. So we find that a very effective way of doing this is to simply have the person say blah, 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 or 1, 2, 3, 4, or cola, cola, cola. Doesn't matter very much what it is, but it does seem to block the capacity to take a visual stimulus and turn it into its phonological representative. So that's a way that you can look at whether the phonological loop is important. Similarly, in the visual spatial domain, you can separately interfere with something visually, for example, by simply processing patterns, pictures or colours, or spatially by having the subject tap, for example, in a square pattern repeatedly. And that will interfere with spatial coding. Now, a complicating factor is that the visual and the spatial are quite tightly integrated. So you don't necessarily get a very clear separation. And the studies that have finally pinned that down and demonstrated it have had to use a whole series of carefully designed and carefully modulated tasks. But these were all based on earlier work that used slightly messier tasks. So a dual task method is a way of trying to knock out a component and see what happens if you're functioning without that. Now, I've spoken so far about the two subsystems. They're the most straightforward, but what about the central executive? Well, there are two approaches to this. One is to try to have a task that doesn't place much apparent load on the verbal or visuospatial short-term memory systems. And one example of this is random generation. If you want to have a task that will keep the subject very busy, that will use his executive processes, then one thing to do is to ask him to try and produce a random sequence of items, for example, letters. What you find is that if you're trying to generate random letters at a rate of 1 per second, you rapidly run out of steam and find that you're falling back into alphabetic sequences or sequences like USA and BBC. And it's, I think, because it's a fairly complex mechanism that involves setting up a retrieval program, pulling out an answer, checking it, emitting it, and doing all that at speed appears to make considerable demands on attentional capacity. Another way of looking at or trying to combine visual, verbal, and executive capacity is to use something called the N-back task. This is a sequence where you present the subject, for example, with a string of numbers. In the simplest, the subject simply reads out each number as it appears. In the one-back task, they read out not the number that's just appeared, but the one before that, much more demanding. The two-back, you have to hold 2 in, and call out the one that's 2 back, and then it becomes really demanding. So what you're doing here is to keep the verbalization a single digit constant, but make the processing much more difficult. Now, you can also do this in a visuospatial mode by having an array of squares, a matrix, and when one of them is illuminated, the subject touches it. That's the 0 back. Or he touches the one that had just been appeared, or the one before that. And so by using these, you can look at the effect of very low load on a visual or verbal, and high load on both. So you can tease apart the relative importance of central executive and phonological loop and visuospatial sketchpad. Now, an obvious question then is, what about the episodic buffer? My answer there is, I only wish I knew. The point about being able to set up interference tasks is that you need to understand the system to know how you can get in there and block it. And at the moment, I don't think we understand enough about the episodic buffer to do that. But perhaps in a year or two's time,